Okay, I've got one of the new control panel kits here. Let's open it up, see what's inside. Welcome back to Cloud42, I'm James. If you have been following the electronic lead screw project on this channel, then you know that the number one question I get is when I'm going to have a kit available for the control panel. Well, today is the day. I have the first 100 kits put together in stock and ready to ship. There will be a link down in the video description if you're interested in getting your hands on one. And if history is any guide, I do expect these to sell out quickly, and that's okay. I'm just a small shop here. I'm just a one-man show. I can ship out 100 packages in one day if I need to. I can't manage 10,000. So we're gonna start with 100, and I'm gonna use what I learned from that to figure out how many more I need to manufacture so that I can keep them in stock long term. So after the first 100 are gone, there'll be a little pause and then we'll get more. That said, let's hop over to the bench and crack open a kit and put one together. Okay, I've got one of the new control panel kits here. Let's open it up, see what's inside. Okay, the kit, of course, includes the PC board control panel and the red plastic lens and the 3D printed plastic spacer. It also comes with the 3D printed rubber buttons and some screws for assembly. And then I decided to go ahead and include the PC board, the actual button and display PC board. These are not very expensive, and so a lot of people have picked them up already, but I have gotten some reports from people who have purchased these that there are multiple layouts for this board available, and some people have reported that the ones that they received didn't actually fit the buttons. So I've got the cutouts in the PC board and the 3D printed buttons set up to fit here and the display to fit in the opening. And I've had some reports that there are multiple versions of this board out there. So they're not very expensive, so I went ahead and just picked up 100 of these and included them in the kit. Mostly because I wanted to find out when I ordered some more, were they gonna fit or were they gonna be different? These turned out to be exactly the same as the ones that I purchased initially. But again, I think it's gonna be more reliable for people if I just include this part in the kit. So for now, that's what I'm gonna do. And we'll see long term if that becomes necessary. Okay, let's start by taking a look at this board. So this has got some surface mount components, the TM1638 controller, and then through-hole parts for the LEDs, the LED displays, and these buttons. And the first thing whenever you get one of these boards is to take a look at it, because sometimes these switches are not fully seated, and so if one of the switches is popped up a little bit, that's not going to work very well for the to get the buttons to fit properly. Or sometimes these LED displays are not all the way down, or sometimes the LEDs aren't straight, but I can just adjust those. Now I can feel, you probably can't see, but this display unit is just slightly high, and that's really easy to fix. All you do is just hold the board so you can put pressure down on it. So it's up a little bit. I'm just gonna hold the board like this and put pressure down, and then I can just come in here with a soldering iron and just heat these joints one by one and just kind of go back and forth, remelting the solder joints, and I can already feel it settling. But that's all I'm doing is just reheating these solder joints while putting a little bit of pressure down on the top of the board. And that's pretty much it. It's pretty much level. I'm gonna touch this just a little bit more. It's almost flat, and I want to get it completely flat. And again, you're only going to get a little bit of movement on each pass, so you just kind of go back and forth, melting these one at a time, and it'll gradually settle in. Yeah, now it feels almost completely flush. And you can do the same thing with the buttons. Just put a little pressure down on the button, and then just come down here and just touch these joints. Now in an ideal world, this would be not necessary, but in that ideal world, these boards would be a lot more expensive than they are too. So these are the little things we put up with. Now, the other thing that needs to be done to this board in order to make this work with the control panel is you can see there's a pin header connector here, and it points up. I have no idea why they did this, probably because it's convenient, but any application where you're going to use a board like this inside any kind of an enclosure, you're going to have a panel over the front, and that's just in the way. So this has got to come out and either be replaced on the back or replaced with a different style of connector. I typically use a right angle connector and put it on, reinstall it on the back of the board. And if you have purchased one of my interface board kits for the electronic lead screw, they actually come with an additional 5-pin right angle header like this. But this is just a 2.54 millimeter spacing standard header, 0.1 inch header, and you can get these anywhere if you decide to do this on your own without getting the kit. But this has got to come out, and it can be kind of tricky. If you've got a good desoldering pump, that's a great way to go. But if not, you can actually do this pretty easily with a soldering iron. There's a little trick. So I'll put this in a vise, make it easy to hang on to. Get it here where you can see. And get my Optivisor so I can see. And the trick on these is you can take these pins out individually, because as they heat up, the plastic softens. So I can just take a pair of pliers, grab the first pin here, and I'm going to brace with my thumb down on the board below, just so I have something to push against. And you can just heat up the joint. And this is lead-free solder, so it's kind of hard to see what's going on. So you get that completely heated, and then the pin will just pull straight out. And you can just repeat that and go right down the board and pull all the pins, and the plastic part of the header will come off with the last pin. And then come back and clean out the holes with solder wick. Now, that's kind of a pain. If you actually have a desoldering pump, which I do, you can use that as well, and it's a much easier option. So this is kind of a smoke 'em if you got 'em situation. And I'm gonna apply some flux to the back of these connectors just to make the solder flow better and flow better against the tip of the desoldering pump. And then I'm just going to go ahead and desolder this. But like I said, you can do this easily with a soldering iron and wick too. But if you've got it, this is by far the easiest way to remove it. I'm going to go ahead and add a little bit of solder back to that one that I did with the iron, just so I can get a clean extraction and clean the hole out with the pump. And there we go. You can see light through all the holes, nice and clean. And before you solder anything else on here, you can sort of clean up the surface and clean up the old flux with fresh flux from a flux pen. This is a nice little trick. You can do this with isopropyl alcohol also. Now this is a no clean flux, which means that this is Kestra 951. It's a no clean flux, meaning that you can leave the residue on the board and it won't cause electrical conductivity problems and it won't cause corrosion on the board. So you can leave this on there long term. You don't have to clean it up. If you don't use a no clean flux, you'll want to clean the board afterwards with isopropyl alcohol. Okay, so I've got my right angle header and I will just stick that in from the back. Now to get this in, you can notice that there's some movement here. And to get something like this soldered in cleanly, you need to hold it in place. And there's a neat little trick. You just take a pair of tweezers and you can reach between the pins and squeeze it against the board, and then take a clothespin and clip it onto the tweezers, and now that will stay in place. And you can get it positioned where you want, and you can do your soldering on the other side. And what I usually do then is just come in and solder one of the pins. And now you can take this off and it will be held firmly in place, and you can adjust, do any adjustments you need and get it positioned where you want it. And then you can come back and solder the rest. And I'm using lead-free solder here, and that's what would have been on this board originally, but there's no shame in using leaded solder. You're probably best off if you completely clean the board first if you're going to use leaded solder, just so you don't get a little bit of leaded solder mixed in with the lead-free. Over time, that can lead to all kinds of problems with tin whisker growth, but generally that's more of a problem in like aerospace applications than it is in the home shop. Okay, that's the new header on the board, ready to go. Okay, now that we've got the board ready to go, let's go ahead and put it together. Now you'll note on the top of this, there's kind of a clear tape, and that's just to protect the surface of the LED here. It has a matte surface so that it won't be reflective, and this is to protect that, and you can just go ahead and pull these off. So now you have the matte surface, so you get less internal reflection behind the lens in the display. And let's put this thing together. So you've got the actual PC board itself with the cutouts for the for all the buttons and the lights and the display, and the nice silkscreen surface with the labels on it. You've got the plastic lens, and this has got protective film on both sides of it to keep it from getting scratched. And then the spacer, and the spacer goes on the back of the board to space this off of the back of it. Now, when this lays down on here, you see it's got these fingers that come out. These are just 1 millimeter thick spacers to go around the screws in the corners, so that if you do want to mount this in a bud box, that additional 1 millimeter space will bring the front of the PC board flush or close to flush with the front of the box. If you don't want to use the 124 size bud box, you can actually just snap these off. Just take these aren't wire cutters, but just take wire cutters and just trim them off. Or you can bend them back and forth and break them off. And then you'll just have the spacer on the back of this board, and you can just cut a hole to accommodate the electronics, and then just mount this on a hole in a larger panel with 4 screws. So either way you want to do it is fine, but I went ahead and 3D printed these with the 1 millimeter thick spacers on the corners to accommodate use in the bud box. Okay, let's start with the panel and crack open the screws here. So to mount the electronics, there are 4 of these M3 by 16 button head screws, and there are 4 nylon lock nuts to hold that all together. And then these 4 are 632 screws that are for mounting this in the front of a bud box if you choose to go that way. If not, you just got 4 free screws. Okay, so we'll take this and just go ahead and drop one of these 3 millimeter screws in each of the corner mounting holes here. And the easiest way to do this is to put those in first and then lay this down on the bench and then stack everything else on top of it. So next thing that goes on is the lens, and again this lens has a protective film on the back, and it's easiest to just grab a fingernail and kind of scrape it until you've dislodged a little bit of it in the corner. And you can peel that off. And there's another one on the other side. And if you start all your peeling from these bottom corners here, where it's not actually going to be exposed in the end, then you don't risk damaging the clear part of the lens. Then you can just set this down over the screws and it should just drop in. Okay. And then this 3D printed part was printed with this surface down on the plate, and so sometimes you get a little bit of squeeze and a little bit of lip, and so sometimes it's hard to press the screws through, so I'll just deburr these 4 holes. And the quickest and easiest way to deburr the holes is with a tool like this. It's a little Noga rotary tool, and you just stick it in there, give it a swipe, and it'll just take put a tiny chamfer on there and take off just a tiny curl of plastic. And you can see like that one on my thumb there. And then this should drop easily over the screws as well, if I can get them lined up. Okay, so that's on, and then you gotta lay the buttons in, and you'll note that one of the buttons is smaller and one of the holes is smaller. So that just fits in like that. Arrow buttons, and then this just goes down over it, and the 4 nylon lock nuts go on. And you won't be able to spin these down all the way without tools because they have a nylon insert in them and the screw will just spin. And then I'm using a 2mm hex drive screwdriver or 2mm Allen to snug these down. Now you are squeezing against a plastic spacer, so just run them down until they're snug. There's no reason to tighten these because you can actually crush the plastic. And I do have a nice set of nut drivers that are real handy for this, but they're like 6 feet away from me and I don't want to go over and pick them up. Okay, next thing you're going to want to do once you have this together, I mean this is basically assembled, you're going to want to check the action of the buttons. Make sure you get a good, nice, free click and that they return up. And if they don't, now is the time to make adjustments. Like one of the things I've seen is if the buttons are raised up a little bit, if one of these buttons isn't fully seated on the board, there won't be enough space, and like you might click the button and it doesn't pop up or it doesn't feel quite as free as you'd like it to. These all feel great. If there are any kind of little bits or any artifacts on the side of the 3D printed buttons, sometimes they get hung up in the holes a little bit, and you can watch out for that. And again, you can just trim any of that with a razor knife. I haven't had any of these in this latest batch. Haven't had any issues with them. And then the other thing is if the buttons are too loose for your liking, you want them a little bit loose just so they can move freely, and so there's not, you try to make these things too tight and too precise and too much of a machinist fit, then it just doesn't become practical and they just don't, the action isn't very good. But if they're too loose, the buttons can rattle around a little bit, and depending on the machine you mount it on, I don't know if they might make a tiny little bit of noise. They are soft. But if any of that bothers you, you can shorten these standoffs slightly. Just take it back apart and just use a little bit of sandpaper on the tips of the standoffs for the PC board spacer, and you can shorten that spacer and that will tighten it up. If you want to use something different for a lens, or maybe put in a PET clear sheet for additional protection or something else, you'll have the same issue. Anything else you sandwich in here is going to increase the spacing, but you can always just shave down that spacer in order to make it fit. And then if you want to put it into a bud box, this is a CU124 bud box. I'll put a link down in the description if you want to go this route. I've gotten mixed feedback. Some people say, oh yeah, absolutely, you have to use the metal box. Other people are saying those aren't really available where I am. I'm not reselling these at the moment. If there's enough demand, I can do that. But I'm not really adding any value. I'm just adding costs because I got to mark them up to make it worth my time. So I have avoided doing that for now, just to keep the cost of the kit down and make it more accessible and more flexible for people who may not want to use the box. But this will just drop straight in, sit flush, and you put in these 632 screws to hold it in. Now, one thing to note about these boxes is that when they come initially, the holes for the screws in the corners are not threaded. They're intended for a 632 screw, and they give you the screws for it. But these are trilobular screws. If you kind of hold it and turn it, you can feel that the screw is not round. It's actually kind of triangular with rounded corners. And these are designed for forming threads in the holes. So if you plan on using this, what I would do is take the screws that come with the box first, and I would do it, with the lid on, just so everything centers upright. Put those screws in, take a screwdriver, drive them in all the way down, and then take them back out, and that will form the threads in that hole. Alternatively, you could just use a 632 tap and tap them. But once you do that, then you should have no problem dropping this in and running these screws down to tighten it in place. But these screws will not form threads very effectively, and you'll just have a terrible time putting it together if you try to put these in directly. I did look around to see if I could find a trilobular screw that would work with this, but finding a 632 trilobular thread forming screw in black oxide to match the aesthetics, in a socket button head screw to give that nice smooth look on the front of the box, I could not find those. I know that's a lot of requirements, and so it's just as easy to form the threads with the screw that comes with the box and then put these in after the fact. Okay, that is pretty simple. I will take this over. Let's go take it over to the lathe and plug it in and just make sure that it works. Okay, let me take the old control panel off of the lathe. And of course it looks exactly the same because this is one of my prototypes. Dropping the screwdriver is great. You get some extra squats for the day picking it up, but it's optional. These are those same, actually these are not the 5/16 screws, these are some longer ones that I actually modified for the prototype before I ordered the correct ones. And the previous PC board was actually a little bit tight in there as well. So let me make sure I know which orientation this wire goes, and I'll pull that off. And here's the new one that we just assembled. Put the connector in. And I'm going to set this in the box, but I am not going to run the screws down. I'll put one in just to make sure I don't drop it. But I don't want to scratch this up because when I'm done here, I'm going to put this back in a box and sell it, and one lucky purchaser is going to get one that's already pre-assembled. So if you get one that's already pre-assembled, it's either this one that you watched me make in the video, or it's the one that I did to test once I had the kits put together initially. So let me power this up. And it appears to work. Check all the buttons, up, down, inch, millimeter, feed thread, forward, reverse, settings button. Of course, there's no settings in this version of the firmware, and the power button doesn't do anything yet, as has been discussed ad infinitum in the comments. I will get back to that at some point. But so this is working. I will go ahead and take this back off, put it in a box, and if you get one pre-assembled, might be this one. If you are interested in getting one of these kits, there is a link down in the video description. And as always, I welcome your feedback in the comments. Thank you for watching.